Good morning. So last class we did insertion of an element at a given location in an array. We did the trace of it, we did the program as well as the algorithm. And then we saw the execution of it also. In today's class, we'll start with deletion of an element from an array. So at a given position, this is also your practical program. So what do you mean by deletion? That is, it is used to delete an existing element from the given collection of data items. That is, if you want to delete an item at a given position. Here when I say item, I am not checking about the value of the item. For example, I have 1, 2, 3, 4, 5. These are the elements of the array. This one is at the 0th location, this one is at the 1, 2, 3 and 4. I am only speaking about the subscript value here. I don't say I want to delete an element. Suppose this is 14. I want to delete 14. That is not possible. Like, it is possible, but we are not doing that. Okay? We are not deleting 14 there. It is possible. I can go and check with each one and then find out the LOC and then delete that. Yes, it is possible, but when I say deletion, I will say delete an element at the subscript value or the index value 3. So this element, immaterial of the value whatever is present, gets deleted. That is what I am going to do here. Like when I say deletion of an element, I mean to say I will ask the user to enter the location which is nothing but your subscript or the index value. Like when you enter 3, then you need to delete the value or the element present in that location. Hopefully you have understood what the program is. So let me say I have an array A, okay, of 5 elements, wherein A of 0 is 23, A of 1 is 45, A of 2 is minus 30, A of 3 is 18 and A of 4 is 6. So these are the elements and the maximum size of the array is 5, and I have stored this like 1, 2, 3, 4, 5. When I said deleting an element, for example, I want to delete an element at the position 2. Okay. So what should be the resultant array? The deleted element is equal to minus 30. Yes. Position 2 minus 30 is present. This is the deleted element and the resultant array must be 23, 45, 18 and 6. So A of 0, A of 1, A of 2 and A of 3. So array size here n value is 5 and here n value is 4. So what are you doing here? When you delete, this element gets shifted here and this element needs to be shifted here and the size of the array is reduced by 1. So this should be the resultant array. So you need to write a program or an algorithm which will do this operation. So hopefully you have understood what I mean by deletion of an element and what is expected as an output. Please have a look here. Now we'll go back to the question. Like deletion statement. Deletion is used to delete an existing data item from the given location of data items. Yes, correct? And see, that is what they are saying. So A of 2 is 30 here, and if I say I want to delete an item at position 2. So what should happen? Element at position 3 should be shifted to 2 and from 4 to 3. That should be the operation, so that this one I will reduce n is equal to n minus 1 automatically. This is taken out of the array and I will print. The size of the array would become less by 1 because number of elements, you delete one element. So, the number of elements in the array is reduced by 1. Hopefully, if you are getting my question here or what I mean to say, right? We will go through the algorithm once I write the program, because once I write the program and come back to the algorithm, it is easy to understand, and then I will also show you the execution of the program in Turbo C++. So, if you have TC, you can also execute it and see, because all these are your lab programs also. So, shall we start with the program then? How do I do that? Hash include. You can write it along with me. iostream.h hash include conio.h. Then let me have a class. Since this is a lab program, I would want you to write a class programs only. Class array delete, since it's an array. And one more thing, only delete you cannot use in lowercase, because delete is a keyword. You use new and delete to dynamically allocate and deallocate memory, so I cannot change it. So you want to use delete, then either use it in uppercase. I would suggest not use any keywords in whatever case as the names, identifier names. So I will say array delete, yes. After that, in the private section, let me have int ARR of 10 and then NI position, and the deleted element I need to store, let me say ELE. I can directly print like that only without storing it in EI or ELE also. Like I can say A of whatever is the location will print me that, but still let me have an element variable which will hold the deleted variable. So these are the data members of my class, which has an integer array ARR maximum of 10 elements. N is the number of elements in my array. I will be using it for loop. Position, wherein the user will enter the position of the element to be deleted, and then ELE will hold the deleted element and print it on the screen. So these are the data members. In private, let me have void input. Next is void del delete, and next is void display. End of my class. So this is data members, and these three are member functions. See, I have array delete is the name of my class. In the private section, I have data members. This should be public. So in the public section, I will have void input, void del, and void display. This D is in caps, okay. Void input is to take in the number of elements in the array and also the array elements. In delete, and I will also print the array elements in input, and in delete, I will ask the user to enter the position of the element to be deleted, and then I will check whether it's a valid position or not. If it is valid, then I will do the deletion operation. Otherwise, I will write invalid position. Then what am I going to do? I am going to print the resultant array, that is array after deletion, in the display function. The array before deletion I would have printed it in the input function. In DL function I will ask the user to enter the position, and if it's a valid position I will delete the element and then reduce the size of the array by 1, right? Because when you delete something, the array size is reduced by 1, and then void display, which will display the element, or display the array after deletion. Getting it? Yeah. Please have a look and make a note of it. Now let me start with the input function. So how do I define a member function outside the class? The return type of the function, the name of the class to which it belongs to, scope resolution operator, and name of the function with the argument list if it is there, otherwise it is blank. Fine. So let me start. Void is the name of return type of the input function. Array delete is the name of the class to which the input function belongs to, and there are no arguments, so I am not writing anything. So I will say here the first would be ask the user to enter the number of elements in the array. See, I have declared an array with maximum elements, but then as a user I can decide how many elements I want to have in my array. So I will ask the user first, see out, enter the number of elements, enter the number of elements in the array. Yes. So see, in n, I am storing it in the variable n, which is already declared in the private section of the class array delete. After that, what should I do? I should ask the user to enter the array elements, because I know the number of elements. Now I need to ask the user to enter the array elements. See out, enter the elements of the array. Then, since it's a repetitive action, for I is equal to 0, I less than n, I plus plus C in ARR of I. Yeah, I am taking in the values of the elements in the array. Like, I am asking the user to enter the elements of the array and I am taking it. So 0 to n minus 1 is the n number of elements. Later I will print it here only, because in the display function I will get the array after deletion. Once it is done, since the same array you cannot get back the previous one. So let me print it here only. How do I do that? See out, the array elements are and L. So for I is equal to 0, I less than n, I plus plus, C out. After that, ARR of I single quote backslash t. That indel is not required. Single quote backslash t. So what am I doing? Then I will close my for and function here, input function. So what am I doing here? I am asking the user to enter the number of elements, taking in the number of elements into n, and then I am asking the user to enter the array elements, and then I am reading the elements from one by one and into the array. After that, I am printing the elements. Whatever you have entered, the same thing has been printed here. I need backslash t because it will give a tab space between the elements. If there is no space, it will appear as a single element even though there are more than one, like n elements are there, but since there is no gap, it will appear as a single digit. So you're not sure which element belongs to which location. So that is why give a tab space, or you can print it one below the other if I give just an ender, right? And then I'm closing my for here and I'm closing my input function here. Please have a look and make a note of it. Now I will start with my delete function, right? I will write the trace also here itself so that you can understand it well. Return type of the function is void. Array delete is the name of the class to which it belongs to. Del is the name of the function. So what will I say? Cout enter the position of the element to be deleted. You are not taking enter the value of the element to be deleted. No, you are taking in the position of the element to be deleted. Cout enter the position of the to be deleted. Okay, you are taking in, you are asking the user the location or the position of the element which has to be deleted. See in POS, we have declared this variable, right? I have taken in the position. So again, now I have to check whether it's the valid position or not. So suppose the position is anything less than 0, it's not a valid position, correct? Because I don't have negative positions in my array, or it is greater than n minus 1 because the last element, the subscript of the last element is only n minus 1, that is 0 to n minus 1. If it is greater than n minus 1, I am not talking about equal to here, I am talking about greater than n minus 1, where there are no elements at all, then you have to write invalid position. So I will check if, what I should say, position is less than 0. Anything less than 0 is a negative number. So less than 0, or if one of that is true is an OR, both are true is an AND. OR belongs to what? It's a logical expression, correct? It's a logical operator and we use OR to write logical expression. If position is less than 0, it's a logical operator. Or I'm writing, see, this is one part of it, or position greater than n minus 1. I'm not talking about equal to here. I'm talking about greater than n minus 1. So the elements are 0 to n minus 1. There is nothing here. If I give the n value also, it will go because there is nothing over here. The last element itself is n minus 1. So 0 to n minus 1. If position is less than 0 or position is greater than n minus 1. OR gate, how does it work? Like a logical OR. If one of this is true, like suppose if this is true and then this is false only, because if I enter minus 5, definitely it will be greater than, sorry, if it is minus 9, how it will work? Both are true, like, yeah. Or I say 10. For example, if I say 10, definitely this will be false because 10 is not less than, 10 is not less than 0, so it will be false. This will be true. If the number of elements are 5, there are totally 5 elements in my array. If I say the position to delete is 10, this will give me a false value because 10 is definitely not less than 0, and this will give me a true value. Yes. So for an OR, if one of this is true also, then it becomes a true. That is 0, 1 is 1, 1, 0 is also 1, 1, 1 is 1. When I say 1, it means true. And 0, 0, when both the conditions are false, then only it is a false value. But then I am saying if it is less than 0 or it is greater than n minus 1, then you have to write it as an invalid position. Yeah, hopefully you have understood this. Please make a note. The next thing what I have to do is to check if it is the last element. Like I have 1, 2, 3, 4. So the position of this is A of 0, A of 1, A of 2 and A of 3. So if I want to delete this, what I can do? I can directly take this out and reduce the array size by 1. It will go here. I don't have to do any shifting, right? Because this is the last element. Which would be the last element? Number of elements is 1, 2, 3, 4. So n is 4. So n minus 1, that is 3. Correct? So the thing is, if you want to delete the last element, you just have to delete it and reduce the size of the array. Automatically it gets deleted. So let me start with the if else, like else if statement, because that is also one more option where I have to delete the element, that is the last element. So what I can do is I can say else if position is double equal to n minus 1. If the position is n minus 1, what will I do? First I need to store the element in that position, correct? So ELE is equal to ARR of POS. Then see out the element, deleted element ELE. Fine. After that, in the end I will reduce the size of the array. So let me make it as this. So one more condition is done, that if the element, if it is in the last position, like for example I have this is ARR of 0, ARR of 1, ARR of 2. So I want to delete the element in this position, because what is the value of n? N is 3, because number of elements is 3 and the position is n minus 1, that is 2. So if I want to delete that directly, I can take it out, because I need not shift or make any changes to the previous elements, because it is the last, and I will say n is equal to n minus 1. So what happens? N becomes 3 minus 1, 2 elements. So 0 and 2 are the 2 elements, correct? The same thing, 0 and 1 are the 2 elements, because it becomes, the value of n is 3 here. When I say n is equal to n minus 1, n becomes 2. So it will be ARR of 0 and ARR of 1. 2 elements are there, this gets deleted. There is no need of any shifting here, because I am deleting the last element, that is the element present at the n minus 1 location. This is the thing what I am writing for it. Please have a look. Then what will I write? Else what I have to write? If it is like anywhere in between, I want to, it's a valid position and it is not the last position, then I need to reduce, that is I need to change. We did that, right? That is, for example, if the position is 1, then I need to put the previous, the second position element to 1 and the third to 2. Like that I need to shift the elements to 1 before. Then only the array size will reduce, and before that I need to store the element at the position, because before rewriting it to position 1 plus 1 element, I need to store it. Let us write this, and I will write the trace so that you will understand it better. So let me say else. Else does not come with a condition, only if and if else. But else does not have a condition. If nothing of that is true, what will I do? I will say cout. Before that, let me say, before cout, I will say ELE is equal to ARR of POS, the element in that position. After that, I will say cout the deleted element ELE and done. So I deleted the element and I printed it. Now I need to shift the array elements. So what will I say? For I is equal to position I less than n minus 1, I plus plus. ARR of I is equal to ARR of I plus 1. Then I will put this. This is the end of my function. Else also, this is the end of my let me not write the end of the function. I am writing the end of the else. Like here my else ends, here my for ends. Okay. Let me write the trace of this code. For example, I have ARR of 0 is equal to 6. N is 6. 6 elements are there. So 0 to 5 will be my elements. ARR of 1 is equal to 12. ARR of 2 is equal to 5. ARR of 3 is equal to 2. ARR of 4 is equal to 6. ARR of 5 is equal to, so 16. Let me make it as 16. This is 18. Okay. This is the elements which I store in my array. The n value is 6. For example, I need to delete an element at the position 3. I want to delete an element at the position 3, or okay, let it be 2. I want to delete an element at position 2. So what should be the resultant array here? So we'll write the trace of it and then we'll find out the resultant array. I want to have ARR of 0 is equal to, see, I starts from position is 2. So 0 remains 6, yes. Then ARR of 1 also remains 12, correct? It doesn't change. Then I is equal to position I less than n minus 1. What is n minus 1? N minus 1 is 6, because n is 6 here, n minus 1 is 5. So I is equal to 2, I less than 5, I plus plus, correct? Am I making some sense here, right? I is equal to 2. Yes, because I have entered position is equal to 2. Then I less than n minus 1. What is the value of n here? 6, because I have 6 elements here. So n minus 1 is 5. So I less than 5. That is 2, 3, 4. 3 times the loop will run, because 5, when I takes the value 5, 5 is not less than 5. I plus plus. So ARR of 1 I have written. Now I'll say ARR of 2. What will it be? I is equal to position ARR of I. So ARR of 2 is equal to, see, I have already written this here. So now when I rewrite also, it's fine with me, correct? But if you try to write it after the change, then you will not be able to retain that. That is why when you are deleting, first note down the element or store the element in that location in a variable and then write the for loop, because once after the for loop execution, the element would have got deleted and you will not be able to retrieve the element which was present in that location. So ARR of 2 is equal to ARR of I plus 1, that is 2 plus 1, 3. So what is there in ARR of 3? ARR of 3 has the value 2, so it comes here, right? And now what will be ARR of 3? It will go back, increment the value of I. So ARR of 3 is less than 5, correct? It will come here, ARR of 3, so is equal to ARR of 3 plus 1, that is 4. What is 4? 16. So this gets rewritten there, okay? Now I gets incremented by 1. So what will be the value of I? 4, correct? 3 was there, 4. 4 is definitely less than 5. So what am I doing? What am I going to do now? I'm going to write ARR of 4, that is I is 4, is equal to ARR of I plus 1, that is 5, correct? 18. So ARR of 4 is 18. So what was my resultant array? 6, yes. 12, yes. Because I am deleting the element 5, because at the position 2, 5 is there. It is not there here. I have moved 2 here. Yes, ARR of 2 is 2. Then I have 16, which is moved 1 position higher. That is ARR of 3, and then I have 18 moved 1 position here. So array size has reduced by 1. Yes, 1, 2, 3, 4, 5. So n value is 5. What was the n value here? 6. Here it is 5. So hopefully you understood this. Please go through this. What I am doing is, first I am going to store the element in that location, because once I start rewriting it, then you will not be able to retrieve it. After that, start the counter where I is equal to position, because in that place I have to write position plus 1th element, right? Because the array size reduces by 1 here. So position is equal to ARR of I plus 1. Why is it n minus 1 less than n if I write also? What happens when less than I means 5 will also take. After 5, when I say ARR of I plus 1, there is no value over here. So I will say I is less than n minus 1 I plus plus. ARR of I is equal to ARR of I plus 1, that is ARR of I is equal to ARR of I plus 1, that is the next element. Like this you go on writing it in the loop. By the end of the loop your array size also would have been, like you can reduce the array size 1 by 1 because you are rewriting on that particular element. Please have a look. See, when this element gets rewritten, but this element will not be shifted, so it won't be blank here. When I reduce the size of the array n is equal to n minus 1, when I start reading or writing, I don't have to worry about this. Now let me do the display function. What is the display function do? Before that, I haven't completed my del function, right? So what I have to do, I have to reduce the size of the array. Only if it is a invalid input or invalid position, I cannot reduce, because I cannot delete anything. My array size remains as it is, as long as the position is invalid. But if the position is valid, either it can be n minus 1th position or anywhere in between, my array size should be reduced by 1, because I am deleting the element. So I'll say if POS is greater than or equal to 0, 0 is the first element, okay, and position is less than or equal to n minus 1. So if both the conditions should be true, like this also should be true, this also should be true, and as always both the conditions should be true for this if to execute in, or it is one of the conditions is true, then the thing will execute in, and both the conditions should be true. What will I say? If both the condition, that is position is not negative, greater than or equal to 0. If it is equal to 0 also, it is the first element, so it will be equal to 0, and position is less than or equal to n minus 1. If both the conditions are true, I will say n is equal to n minus 1. Because there are valid positions and I would have deleted an element. If the position is not valid, then there is no point in deleting the size, because if you have not deleted, then you cannot reduce the size of the array. The array remains as it is because the invalid position was entered by the user. This is for if, and this is for my function del. I end my function here. After that, what should I write? I should write my display function, right? Return type of the function, name of the class it belongs to, scope resolution operator, name of the function. So cout and del. So I'll say for I is equal to 0, I less than n, I plus plus. Cout ARR of I, and I will say backslash t in a single quote, which will give a tab space between the elements. After that, I will close my function. So my function is done here, my for loop is done here, and I'm printing the resultant array if the position is valid, correct? Now I will write the main. Void main clear screen So this is my function. Hopefully you have understood this. This ends my main function as well as the program. I'll show you the execution of it also. Please make a note. Then we will go back to the algorithm of that and try to understand. Then I will show you the execution. So now we'll go to the algorithm. So what can, wow, see n minus 1 also doesn't matter, but yeah, n minus 1 or less than, n less than, or you can write n minus 2 here. So you will go down to n minus 2. A n item position. So because in the program what did we write? I is less than n minus 1 I have written, or you can say I is less than n also. The program will work perfectly well. It doesn't make difference. Maybe when I execute the program, I will write both the conditions and I will show it to you. I'll change it in the loop and I'll show it to you. A is an array with n elements. See, this is very important. Item is the element to be deleted in the position POS and is to be stored in a variable. Because position, I have element, I stored the deleted element in a variable called ELE. Same way here they have termed it as item. A is an array, okay. Delete a n item pos. A is an array, n is the number of elements in an array, item is the thing which has to be deleted in the position POS. So you are storing the element which is present in the location into variable called item. So item first, before deletion you need to take in that, otherwise after deletion you will not be able to retrieve it. For I is equal to position to n minus 1, you go and increment the value of I. A of I is equal to A of I plus 1, that is this one to this one, like this you go on doing it. Then n is equal to n minus 1, yes, otherwise it will print me the last element twice. So I is equal to n is equal to n minus 1, and then you put for I is equal to 0 to I less than n, I plus plus, the same thing will work. So this is the algorithm for deletion, an element, for deleting an element from a array. Please have a look. We'll start with the execution of the program. Which program did we do today? We did insertion of an element program, deletion of an element program. So we will say array delete, okay. I've already, whatever code we have written in the class, the same thing I have written it here. We'll say array delete. Then we had declared all of this. Input array element. I'm asking the user to enter the number of elements, and then I'm entering the elements and I'm printing it also. After that, in delete, I am asking the user to enter the position, and if position is less than 0 or position is greater than n minus 1, it becomes an invalid position. Else if position is equal to n minus 1. That is the last element I want to delete. I'm directly deleting it. See here, I have not storing it in a variable. I'm just giving directly the location there. ARR of n minus 1 will also be the same. After that, if both of them is not true, else gets executed. I'm executing it first. I'm printing the element which is at position which I have, which the user wants to delete. After that, I'm running the loop. I'm checking if the position was valid and the deletion happened. I need to reduce the size of the array by 1. Otherwise, if it was an invalid position, I need not do anything. I need to keep the array size as it is. Then display just will display me the resultant array along with elements with tab spaces in between. Then I have my main wherein I have created an object AD for array delete and I am calling all the functions in the proper order. So this is our program. Let me execute it. Run it. Run Control F9. Enter the number of elements in the array. So if I say 6, enter the array elements. Let me say 1, 2, 3, 4, 5, 6. So these are the elements and it is printing me the array elements also 1, 2, 3, 4, 5, 6 and you can see the tab spaces in between. Enter the position of the element to be deleted. For example, I want to delete 1. From here, what would be the position of the element? It would be the 0 because 1 is in the 0th location because my array subscript starts from 0 to n minus 1. So if I say 0, I want to delete the element at the location 0. It is showing me the deleted element is 1. The resultant array is 2, 3, 4, 5, 6. Yes, the array size has reduced. You can see here. And the array element which is deleted is 1. And the position which it was before is 0. So, you can have a look at the output, right? Now I will run the same program. Let me delete something in between. For example, my size of the array is 6 and I'm entering 0, 9, 8, 7, 6, 5. The elements of the array? Yes. So let me say I want to delete 7. What would be the position of it? 0. 0 is in 0th position, 9 is in first, 8 is in second, so the position of 7 is 3. You can see that the deleted element is 7, the resultant array is 0, 9, 8, 6, 5. So anywhere in between also it is getting deleted. Now let me run the same program wherein I want to delete the element at the n minus 1 location. That is the last element I want to delete. So what are the, let me say 1, 7, 9, 5, 9, 8. So the elements, the array elements are 1, 7, 9, 5, 9, 8. Suppose if I want to delete 8 in this, the last one. So what is the location? It is the n minus 1 location, right? What is n? It is 6. So the location is 5. You can see it gets deleted. Yes, 8 has got deleted. I have deleted the last element and I have the resultant array. Now let me run the program wherein I will give an invalid position. So the number of elements in the array, let me say 5. Enter the elements 1, 9, 0, 5, 6. Yeah. So the array elements are this. Enter the position of the element to be deleted. For example, I would say -6, invalid position, and since there is no deletion happening because the position was invalid, the resultant array is same as the entered array. Yeah, hopefully you have understood that. Now we'll exit the program. So hopefully you have understood the deletion of an element in an array. After seeing the execution of it, you must be clear. Please note down today's homework questions. Write a program and an algorithm to delete an element from an array at a given position. So please note down this. Stay safe. See you tomorrow. Bye-bye.